Hello, welcome to Accounting Hub. I'm Professor George Scarpin, PhD in Accounting, and our topic today is measures of variation, range, variance, and standard deviation. Okay, uh, if we know the measures of central tendency, and by the way, we have a video of central tendency, mean, median, mode, and so on, and the video is in our video description. But knowing it is not enough. Both of the distribution below have identical measures of central tendencies. However, the dispersion here on the second one is much larger than the first one. So, or the first one, the number 4 repairing days, much higher than the other ones, and here they are splitted more. How do we see that? With 3 measures: range, variance, standard deviation. Range, difference between the largest and smaller measurement. Variance, the average of the square deviations of all the population measurements from the population mean. And the standard deviation is the square root of the population variance. So, okay, the range, largest minus smallest. Measure the interval spanned by all the data. Here, 5 minus 3, the range is 2. 1 or 7 minus 1, 6. And how do we do that on Excel? So let's go to our Excel file. Remember, all our Excel files are free, and the link to download is in our video description. So here we have a list 40 clubs from Brazil, Brazilian football championship or soccer championship if you are in the US. The 2 leagues, League A and B, 20 clubs each, so that's why it's 40. And here we already have the maximum and minimum, 84 points and 15 because they are ranked in order of the points. However, if we don't know that, or if we don't have them here, how do we find it? There is no range formula in Excel. If we go here on range, there is no range here. So how do we do? We go through the formula. It's equal the maximum of these two numbers here, parentheses, minus the minimum of the same numbers. There are some other ways, but this is the easiest one. And only to double check, 84 minus 15, the 69. So the range here, 69 points. Okay, so this is the first one, the range. And then let's go to the next one. The variance is the average of the square deviations of the individual measures from the mean. For a population of size n, the total population, the variance is the deviation. So the observation 1 minus mean squared plus the squared difference from observation 2 minus mean, and so on until the end, divided by the number of population. If we are working with a sample scenario, not the entire population, but a sample, then it is the same, but divided by n minus 1. It's a very long formula, lot of work here, but on Excel, we have it. So population variance, and here, that is what we should use because we are working with the full population of the 40 clubs. So equal VAR, P or S, population or sample. So population, and then we have all that long formula here. So, okay, It is very useful for regression analysis and so on, especially if we want to do it on hand. It is very, very useful. However, let's go to the variance here. What if, instead of the full population, this was a sample? So our first 2 leagues, there are 400 clubs, and we are taking a sample of 10% of them, so only 40. Then we will go to variance sample, and then select the numbers. Will be a little bit higher, and the sample variance is always higher than population variance because the denominator, let's come back here, instead of n is n minus 1. So the denominator will always be lower. However, if we are talking a very large sample, then the numbers will be almost the same. For instance, a sample of 2,000 observations divided by 2,000 or by 1,999, the number will not be that different. Even here, divided by 40 or by 39, number is 4. So it's not in 152, not that different. And what is the standard deviation? Is the square root of the variance. Population is square root of the population variance. Sample standard deviation is the square root of the sample variance. And then this standard deviation, so ST-P, standard deviation of population. It is here, the 12 sample STDS. Again, a little bit, and here a little bit higher, because the sample variance is a little bit higher, so the sample standard deviation is also a little bit higher. So because the square root of a higher number is also higher. And this will be very useful for our next videos about the distribution. For instance, if we assume that this is a normal distribution, 2/3 of our numbers will be between the mean, 51, plus minus 12 and plus 12. So it will be between 29 and 63, for instance. Okay, so this is a practical use of the standard deviation. Okay, guys, thank you so much. Questions or comments, leave it here or email me at jscarping@gmail.com. Have a very nice day and God bless you.